Okay, so we're going to start a new file from scratch. We're going to just talk a little bit about the stairs. And on the south side, notice how we have levels from 1 to 2. And just to practice our levels, we're gonna add 4 more levels, architectural level, and then use the pick line tool. Again, we start a new project from scratch, file new, and then select the architectural template to start a new project, a blank project with 2 levels. Once you start that project, switch to an elevation, and we're going to add a couple of more levels. So under the architectural tab, hit the level tool, and we're going to create levels using the pick line tool, 10 foot away with a 10-foot offset. Offset of 10. I'm going to do level 3, level 4, and level 5. Escape. All right, notice how floor plans are created as well as structural plans. And I'm going to open a 3D view. And I'm going to tile this. I want to tile this WT to tile the views. So I'm going to show you how to create a multi-stair level and some of the instance properties of stairs. Again, create 3 more levels, 3, 4, and 5. And while you finish, let me show you my slide deck here. So the stairs in Revit it's a complex family to get a hold of. But you can, if you master it, you can actually create very nice stuff. All of the examples you see on the screen were created using Revit. And Revit allows you to modify the railing families associated with the stairs, the stair material and the stair design. But to get at this level of expertise, you really need to understand how to modify and change the families that are nested inside a staircase. In a nutshell, you have to understand how to create a family of balusters, a family of posts, a family of profiles, and assemble them in this system family. And one of the strategies that a lot of firms utilize to make sure users have access to stairs is to create a project model with multiple stair types. The BIM manager or the person with most modeling skills would assemble the stairs for you, and then you can just copy paste the definition into your project and modify the shape without the need of getting into the components inside the system family. There are 2 methods of doing stairs. The old method is the sketch method, but the latest method, it's been around since 2012. It's you defining what is the run of the stair, and the run is defined as the lower point of the first riser and the top riser. The line between them, that's called our run. And when we create a run, we automatically create in the thread, the riser, and the nose. Then another component of the stairs is the landings. The landings can also be created using distances, offsets. And then we need to define the supports. The typically stair has two supports, the right stringer and the left stringers. If you have really wide stairs, you may need an intermediate stringers or a couple of more intermediate stringers. And you have the ability to add additional components. And so we're gonna start a stair using the assemble method. And I'm gonna show you different ways in which we can change stair properties. As a system family, the stairs has a lot of different properties. But let's look at that directly in the model. Okay, so we have a model and it has 4 levels, 10 foot apart, level 1 to level 5. And on the first level, I'm going to create a stair, a simple stair going from level 1 to level 2. So under the architectural tab, you're going to find the stair tool. Take me to sketch mode. And the assemble stair is the type by default. And so this is the assemble. This is the typical, actually, typical type. And then this assemble stair, it's code compliant. It will allow you to have a maximum riser of 7 and a maximum thread of 11 inches, which is based on international code, IBC. And the assemble method is based on these 3 components: the run, the landing, and the supports. And so the run has a side. So when you are creating a stair, think of it, you are at the bottom level and you're looking at the stair. A stair is going to be built right in front of yourself. And so if this is you, this is your right hand, and this is your left hand, you're going to create a stair that is right in front of your eyes. And so this is going to be the right location line, right location line. And what that means, this is the line that anchors the stair to the ground. And that's what this parameter is, the run. And you can have the center as the anchor line, or you can have the left location line, left location line, or center location line. It's similar to the walls. The location line is the work plane, the vertical plane on the stair that anchors the stair to the ground. And when you build stairs, you need to make a decision. Is it going to be on my left side? Is it going to be on my right side? Is it going to be a center? If you already have a shaft in the project, I recommend you start with the left line. And let's do that. Let's change the location line to the left. If I do that, then if I give an offset, then it's going to add a positive or a negative value from that work plane. Then you define the actual run width. 3 is the minimum of the default. You can do 4 just to change it. And then Revit is going to do all the math for you. So Your first click is the first run point. So that's the first riser. And then your second point is the last riser. And the last riser is defined by the top level. So in the constraints properties of the stair, you have the base level, and then you have the top level. In addition, you can add additional offsets. You can manually change that. For example, if you want the stair to go several foot above level 1 or below level 1, you can manually add those constraints in the instance properties of the stair. Now, Revit is automatically going to report for you the number of risers created. So notice how at the bottom side of the stair in gray letters, it spelled out the number of risers created and how many risers are remaining. And all this math is automatically calculated by Revit in the dimensions panel of the properties. So if you notice in the dimensions, the desired number of riser is a number that Revit automatically calculates based on IBC rules. So it's telling you to keep the stair less than 7 inches in height. Revit needs to subdivide the distance between level 1 and level 2 in 18 equal spaces. You don't have to do that. Revit is going to do it for you. Revit is also going to automatically assign the tread depth, but you can change that. If you want them narrower or you want them deeper, you can change that. The actual number of risers, which is in grayscale, indicates the number of risers created. And I haven't created anything, and that's why it said just 1. And the actual riser height is the typical riser needed below 7 inches, needed to get from level 1 to level 2. So all of this is fantastic. Revit does it all for you. I remember one of the most difficult homeworks I had in architecture school was to create these sections by hand, and it will take me hours and hours just to do them. Just to find out I did it and correct it, and I have to redo it again. But now with Revit, it does it all for you based on the first level and the second level and a set of rules based on IBC. So your first click is the first riser. The last click is the last riser. And you can just span to the level 1 to the last one. And notice how it says 18 risers created, 0 remaining. This is the run, and the run automatically creates supports. These are stringer families. A stringer, it's in this case is a box 2 inches wide, and it gives a number to the first riser and a number to the last riser. Then just hit the last thing is establish what is the railing you want for the stair. So you go to the railing, and in this railing drop-down list, you have the list of all the railings that have loaded in the project. I'm going to select the guardrail pipe. No, guardrail pipe. A guardrail, it's 42 inches high, and it also has a handrail 6 inches below. And you can decide to put the railing on the thread or on the stringer. I'm going to put it on the stringer. Hit OK here, and then hit the green checkbox. And when you see this in 3D, here is the stair. I'm going to give it a little color here. All right, let's do another one, but this time we're going to do it in 2 runs instead of 1. And in order to create the stair, I need to click 4 times. So I'm going to do it slow so you can follow along. You hit the stair button. And then in order to do this, even to do the runs around the equal size, you know that it's going to need a total of 18 risers to get from level 1 to level 2. So in your math, in your head, you just divide the maximum number of risers divided by 2. And so my first click is the first riser, and I'm going to create 9 risers up. 9 risers going up. That's my second click. And then I'm going to use this align line. You see that dashed line popping up on the right side at the top of the riser. This is going to be my third click. Assuming that the shaft is 10 foot wide, or let's do it 12. The shaft is 12 feet wide. This is my third click. And then my last click is all the way to the bottom, 90 degrees. So again, I'm going to highlight an X. These are my clicks. Number 1. This is click number 2. Click number 3. And click number 4. And again, double check the railing. And the railing has got a lead pipe on the stringer. Click the green checkbox. And I receive a warning, and the warning is related to the internal railing, unable to have a smooth connection. See that? See how the railing has a goose neck condition? Now, if you are an architect and you love stairs, the way to fix that is to shift the second run 1 thread forward, right? So I'm going to do very quickly. You select the stair, edit the stair, select the run, the first run, the second run, and move it 1 thread up forward. Just use the move command. Move from this point to this point. I'm moving it 11 inches. And when I hit the green checkbox, voila, now I have a smooth guardrail with no goose bumps at the top rail. That makes sense?
Do it again.
Do it again?
Yeah, could you? You went too fast.
The move or everything?
The move.
Okay, let me do this. All right, so this is when I finish the stair. To make the edit, select the stair and hit edit stair in the contextual tab. This is going to expose the components. I'm going to pick the second run and then use the move command to move it 1 thread forward. Click the move command, and then my first click is a handle at the bottom riser, and then just snap it 11 inches forward, or you can just type 11 on the fly.
Thank you.
And then hit the green checkbox, and that will take care of that goosebump issue there. All right, so let's see. Let's try to do a stair that instead of having 2 runs, it has 3 runs. But it's going to have 3 runs going from level 1 to level 3. So again, in the back of my mind, I know that it takes 18 risers to go from level 1 to level 2. It takes 36 risers to get from level 1 to level 3, correct? And so 36 divided by 3, it's 12. So I need 3 runs of 12 riser each. All right, with that information in my mind, then I will move forward. So I will go with architectures and stair. And again, my location line is on the left. That is the anchor work plane of the stair. Actual run is 4. And I'm going to do this multiple levels using 3 runs. So first click, then I move forward. I know that I need to go 9 risers up. So when you see 9 risers created in those gray lines, that is my second click. Now I'm going to move the cursor aligned with the top riser, 12 foot away. You can just snap to 12 foot. And this is going to be my third click. And I'm going to go all the way to the, oh, you know what happened? I did not put the top level. So I need to start over. Let's just do another one like this. I'm going to start over. Architecture, stair. And this stair needs to go from level 1 to level 3 in three runs. Oh, there's a total of 35 risers. I guess Revit it did a different riser height calculation. Well, that means it's going to be 12, 12, and 11. And let's see, I could change this. I can manipulate this and change it. And what I'm actually doing is reducing the actual riser height. So on the desired riser, let's move that down to 36, up. Let's increase that to 36. And let's do that 12 even. So again, this is my first click. When you hit to 9 risers, that's my second click. Align to the top riser, 12 foot away. And then it's my third click. Move forward to align, that is aligned with the very first riser. This is my click number 4. And then I'm just going to snap to the existing riser for the very last one. So this is going to be my click number 5, number 6. And I think that's it, right? I didn't have to add more. Oh, no. I divided that by 4. I'm doing 4 here instead of 3. Hit the green checkbox. And what I have on the screen, there you go. It's a stair that goes from level 1 to level 3 in 4 runs. 54 divided. To do it in 3 runs, I need each of them to have 18 risers. We can try that. So this was four runs. If we want to do it in 3 runs, I need to do it 18 risers because it's 1, 2. It's 3 levels divided by 3. Sorry, it's 10 foot apart. 10 times 3 is 30. I need to do it 10 risers each. So let's try that again. Here on the side, stair. It goes from level 1 to level 3. So that is 20 feet high. And 35 divided by 3. I need 12. Let's try that. Let's try that with 12. 12 riser up. That's my first one. 12 foot away. Another 12 foot down. And then the very last one, it's 12. Whatever is left to the top. There you go. So that's my 3 runs. I was doing in 9. I don't know why I did 9. This is 12 feet runs. And the very last one is a little shorter. Hit the green checkbox. And I still have a warning of the goose height. Yeah, and that's how we do multi-stories with different different number of runs. Any question here?
Question: If you want to add a handrail extension on the first step, how do you do that?
Good.
I say like a 12-inch plus the tread width is 11. So if you want to bring a handrail in front of the first step, how do you add that?
Great question. Yeah, you can edit the railing itself. So in here, for example, I have this. This is a single run. Let's see. That is this guy here. In the plan view, to be precise, I select. I'm going to do 2 reference planes here just to be very precise. The very first one, it's the 11 inches right thread, right? That's what the code says.
Yeah.
11 inches. And then the second one, it's the 12-inch extension. And so what I do here is you select the railing, edit the railing path, and extend the railing all the way to the first extension. And then draw a small little line for the flat extension. Escape. I don't need this. And then hit the green checkbox. Again, I have a little segment here of 1 foot, and then I have the rest here. Hit the green checkbox, and this is what you get. The extension plus a flat railing.
Awesome. It looks kind of weird. Yeah, it looks good. Yeah, okay. That was easy.
Now, if you want a railing that, has this curve, then we have to model or create a post family that we can associate with the railing. And I believe I gave you a family of that before. So if you look at the stairs family that I gave you in 2 classes ago, no, the railings, sorry. The railings that I gave you a couple of classes ago. There is a type that has this type of extension, but this is a family, it's a post family. The railing here, when I edit the railing, you see how it's stopped there. It's not extended, but I have a family that it's included in the railing definition. You want to know how that looks like? It's you have to edit the stair railing, look at the balusters, and the name of the family is post round with extension start offset. And then that family is available under the category of railings. And there's a bunch of railings here. This is called post run with extension offset. And this is what the family look like. You can customize this to whatever you want and then embed that as part of the railing definition. So two ways of doing this, via the post family or just using a regular extension. I would say if you're not doing 3D renderings and all you're doing is all you need to do is show a plan compliant stair, then just do it using the railing, just extending the railing, and then fix do all of these via details. And the same is true for the very top. You know, at the top you need just the flat portion, the 1 foot extension, right, according to code. So all you need to do is add an extra 1 foot at the top. And in my 3D view here, let me close this. I will have this railing extension here. Now this post is kind of odd, but that's part of the stair definition. So if I don't like that little post there, then I have to edit the baluster placement, and maybe you do this spread to fit pattern, and it will take care of, it will evenly distribute posts from the first one to the last one. And you don't have those extra posts available there.
Awesome, thank you.
Yeah. Okay, another thing that you might want to know is that these the railings in the railings also have the ability to be to be edited individually. Say, for example, I want this handrail to be extended a little bit beyond the railing. You can tab select, tab select the railing. I tab select just the handrail here, and then I hit edit rail, and this exposes the extrusion of the railing and the path. You can edit the path by adding additional lines. For example, here I could say, now from here to here, go here, and then go all the way down, or do something like this. Then hit the green checkbox. Now I have a return of the handrail at that point. Not sure that looks pretty nice, but that's an option if you want to. You can also do it with the very top. You tab, select the handrail, edit the rail, edit the path, and add the pieces of railing. And now I did this this sort of I did it vertical. No, I don't think you can switch directions. That's the only thing. You can only do it in line with the railing. So I'm gonna do this. Does that make sense, B? All right. Again, railings and stairs, the definition, the internal definitions are complex families. I recommend that we build, if you don't have them in your company, dedicate some overhead time to build definitions for everyone, and then share them so you don't have to build them from scratch every time. Okay. Multi-story stairs. So there's a method by which you can do stairs from one level to another level automatically. Let me do that very quickly here on the right side. So again, I'm going to do regular stairs like the very first one. And this time I'm going to use the right run. So I'm going to define the width of I'm going to anchor the right side of the stair. And again, to get from level 1 to level 2 is 18 risers, so 9 risers up. That is my second click. And then I finish the second run. And here is an option in the Create Stairs contextual tab called Connect Levels. And these allow me to extend the same configuration of stairs to multiple levels. So it's best if I switch to the south, to one elevation here. I switch to the south elevation here. And then I just click Connect Levels, and then I select the levels above. And then the same configuration that's running from level 1 to level 2 is going to go from level 2, 3, 3, 4, 4, 5. Hit the green checkbox. And now you have a multi-story stair that behaves like a single entity. Let's say but I think this only works if you have even space levels. Let's see, I'm going to go switch to the south elevation, and I'm going to create the top level at a very different elevation. So I'm going to offset this 15 foot away. If I select this multi-story stair and connect to this additional level, and hit the green checkbox, you see, does it do it? Yeah, it does it. I think this was a new thing in Revit 2021, the ability to connect or to create multi-story stairs in uneven levels. So at the top level, I have a higher level. This is usually true with commercial, where the ground level is higher than the upper ones. And this whole thing behaves as a single unit. And again, if you have your post families embedded as part of the stair definitions, the extensions will be associated with this automatically as well. All right, there are other types of stairs. Let's see, circular stairs. Under the architecture tab, under the stair command, you have all circular spiral stairs, center and spiral. You have these L-shaped winder. I don't think these are legal, but maybe in old residential like San Francisco type of houses. And U-shaped winder. Let's do a full step spiral. So the way this works is you define the location line. I usually pick the run left, because that's the exterior side of the stair. And let's make it narrower. Let's make it 3 feet. And so the first point is, you can see the instruction here in the lower left side, is the center of the spiral. And then the second click is the radius, the internal radius. You can define it how you need it. If you need it far, if you need it forward. I'm going to say it's 1.5 feet. snap it to the horizontal. And this goes from level 1 to level 2. And click the green checkbox. Now, stairs can be flipped. Let's see, let's pick one of the stairs I have here. If I want to flip the stairs, this little icon that is right here, you can just click on that arrow and it's gonna flip the direction. So now up is in the right side and not on the left side. A few things about the visibility of stairs. This break line, it's at the cut line with the cut plane in the view range. So the view range, remember, is a system of planes that define the visibility of objects in a floor plan. If I reduce the cut plane here, then you see how the cut plane is reduced. If you increase it to 6, then the cut plane is above. And so these are ways in which you can modify the relative location of the cut plane. Other things to know, visibility graphics are broken down by different line types. So when you look at the stairs category in visibility graphics in VG, notice how you have all these above, all these subcategories with the above in brackets, which allow you to turn off the nosing lines above. Everything that is above is the dash line. Let's resize this. So if you don't like all these extra lines in your floor plan, you can just switch them off or just keep it to the minimum. Maybe you just want to keep the outline and the supports. And then same is true for the railings. If you go to the railings category, you're going to see all these handrail lines. This looks a little too busy in my opinion. So you can switch off the above handrails. Or you can switch off the top rails. And it's starting to become a little cleaner. And these are extra things you can turn on and off in the floor plan. So there are ways to control how things are displayed above the cut plane. It's all based on your preference or typical industry standard. I'm going to return to my previous layout. Another thing you may want to know in the stairs business is that under the Annotate tab, you have this thing called stair path. And what this does is just add an extra, like if this arrow can be selected and you can shift it towards the right or towards the left if you use this handle. You can also move the up towards the right or towards the left. But you can actually delete it. And if you delete it by mistake, you can re-add it by going into the Annotate tab, stair path, and it will add it again. This is just in case you delete it. Another thing you can annotate, I don't see this done very often in architecture, but in some residential maybe, is annotate the thread numbers. So it's under the annotate tab, thread numbers. And then you select where you want those. I wonder why it didn't pick my second thread. Oh, there it is. Yeah. And you can do the left side, center, or right side. All right, these are ways to document the stairs. And trust me, I have model, I was in charge of just the stair documentation of a very large project. And I was just doing stairs for a couple of months. And they're never going to be perfect, especially if you're trying to document the way in which the supports and the steel members connect underneath the stair. You're never going to get it right. And so the strategy for stairs is to make them look good at a 1/4 of an inch or an 1/8 of an inch. And then from them forward, resolve everything at drafting details using just 2-dimensional lines. Because you're never going to get the stairs model the way they're going to be built. Unfortunately, stairs are not that friendly in Revit, to my dismay. So there it is, stairs. Any question? Okay, just like anything, stairs can also be tagged. So you can tag them by annotate by category. And then you can tag the whole runs. And or you can do it run by run. I mean, especially when you are dimensioning, for example, you can dimension a run by indicating the number of risers, the total number of risers at a typical height. And there's 9 risers at 6/21/32. You can also tag the type, or if you can also tag the whole assemble. Let me just delete it here. Annotate tag by category. Now I'm tagging the entire assemble, and if I do that, then this tag it's telling me again. This tag can be changed to horizontal, and this is a tag for the entire assemble. 18 risers at 6 inches. Or you can do this in a section. If you create a section and then look this section forward like this, you can also create tag by category. And you can add this in your dimension. It's part of the tag. But the beauty of this, is the sections. It really, at a high level, looks good. But you see, when you start looking at how all the steel connects, I mean, this is what I was talking earlier. This is supposed to be a metal string connecting with a horizontal string, but usually these stringers go all the way to here to the back. Why Revit doesn't do it, I don't know. It's not that smart, I guess. So I would leave this at 1/8 of an inch and then create call out. And in the call out, in a rectangular call out, reference a drafting view I would add a typical steel stair detail here. And add it. And when you click this, you will actually see the drafting view instead of the 3D view. And the drafting view, you can fix everything with detail line. Okay. Any question about stairs? Railings? Uh-oh, give me a second, my car. There you go. All right, let's get started with the parameters discussion. I don't think I'm going to have time to go into the rooms, but let's close the discussion of stairs here. And let's open the file that I sent you guys. It's this rack advanced sample project. I think it was in Revit 2019 version, just upgrade to 2021. And then save it in a place that you can retrieve later. I'm just going to save it in my D drive. So let's go back. We're going to start the process of understanding how to manage data inside Revit. And let's review some concepts that we talked before. Again, you know this, and I've asked this many times. I mean, instance properties are the properties of a single element inside Revit. Is typically what you see in the property dialog box in Revit. It's unique to an object, and all of them can be scheduled. And we have type properties, which are properties that are common to every element of the same type. If you change a type property, you change it for all the elements that are in the type. And so understanding how data works is important because we often extract metadata out of the Revit objects for construction purposes. We are asked by the contractor sometimes to give us quantities, or we need to provide the contractor with a good quality model so that they can do the quantification out of it. And so when I'm going to switch to a 3D view here. When we select an object in Revit, I'm just going to pick a door here. There are parameters or properties that comes out of the box. And then there are properties that we add to the Revit project. These are called custom parameters. Like all these parameters under the other properties are custom properties. And there are two types of custom parameters. The first one is called project parameters. And the second one is called share parameters. A project parameter is a custom parameter that I create on the fly and associate with some element categories. But it's called project parameter because it's intended to be used only in one project, and that's it. It's only created in one project. Project parameters can be scheduled, but they cannot be tagged. And all this time, you know what tag means. That means that I can translate the value of a parameter into a label that is visible in the construction plan. That's what tag means. So project parameters can be scheduled. They can be created. They can be displayed in a tabular display, but they cannot be tagged. I cannot embed project parameters inside a tag and they cannot be made visible using tags. And then project parameters are intended to be used at a project level, one project only. And then share parameters. Share parameters is a custom parameter that whose definition is extracted from a custom dictionary of parameter values. That dictionary is the share parameter file. So share parameters are extracted from a shared parameter file. And the share parameter file, it's a dictionary of parameter definitions that are created by your practice, and that contains the format of the information the way you want to document, or it's aligned with your documentation internal processes. A share parameter can be made part of schedules, and a share parameter can be tagged as well. So this can be tagged, and the project parameter not tagged. And so depending on the purposes of the information you want to add into Revit, whether to decide a project parameter or a share parameter, you need to ask yourself, A, do I need to schedule the parameter? And do I need to tag it? If the answer to these two questions is yes, then you must use a share parameter. If the answer is, no, I just need a parameter, but I don't need to extract information, then use a project parameter. Let me see if I can find a share parameter file quickly here. 1 second. If not, I'll show you in the next class. What does a share parameter file look like? I think I have it on my hard drive, and I don't have my hard drive with me yet. Okay, here's an example. A share parameter file, it's a TXT definition that contain information about what's the format of something that needs to be added into Revit. And a share parameter file, when you open it, the first thing that says here is do not edit manually, and you really just need to, if you don't understand it and you don't want to get into trouble, don't edit the share parameter file. Inside the parameter file, which you can also open using an Excel spreadsheet, you will find something called the GUID, and write this down because this is in the test next Thursday. The GUID stands for Global Unique Identifier. GUID, Global Unique Identifier. And the Global Unique Identifier, it's a 32-character string that it's Revit way of identifying a parameter. So Revit doesn't identify a parameter by its name. Like if you create a parameter and you call it, if you call it fire rating, for example, Revit, the way Revit is going to understand and quantify and schedule elements in Revit is not based on the name, it's based on the global unique identifier. Because these unique number, this 32 character number must be unique and needs to be used across multiple models in order for information to be stacked in the same schedule. So I'm going to do a quick diagram here. So if I'm creating I am tasked to create a door schedule of a campus, and the campus has 3 models. Model 1, Model 2, and Model 3. 1, 2, and 3. These are 3 different projects. And if I want to generate the same door schedule for the 3 models, the door schedule, each of these 3 models must have a parameter with the same global unique identifier so that Revit can stack in the same schedule the source of information. And so the share parameters, the reason is shared is because multiple models can grab parameter definitions from this text file and make sure that information is consistent and is schedulable across multiple projects as a Office standard. And so the share parameter file, it's like the book of your information for your practice. Usually there's only 1 per company. Big companies like Gensler and HOK, they have share parameters by practice. So interiors have certain needs of information that are different from airports, that are different from landscape architecture. And so each practice has its own set or its own book of shared parameters. And then the BIM managers are in charge of maintaining and making sure that the families and the project have the access to the appropriate shared parameter file. So when we create maybe this is too much, but I want you to understand how it works. When we create a new parameter, a custom parameter that needs to be tagged and scheduled, we need to add it to this book of definitions and store it in a shared location so that it's accessible by multiple people across the organization. It's like a library. You actually lock this file, make it read-only, so that it cannot be deleted by mistake. But it's a file that we're going to make use in the next exercise. So I probably don't have time to complete the exercise about shared parameters, but let's just save this file. And next time under the Manage tab, we're going to create a new shared parameter from scratch. And then we're going to create schedules. We're going to create rooms. We're going to create finish schedules using custom parameters. So all of that is under the share parameters here. Next class, we're going to talk about share parameters. So, all right, it's 7:10. So let's save this file. Again, if you got stuck on the stairs and want to stay along with 101, feel free to stay over or feel free to disengage. Any questions? All good? All right.